All right, so this is our last one. We're using the squeeze theorem to show that this limit x goes to 0 of x to the fourth times 5 to the cosine of 1 over x. It doesn't matter too much, but I'm actually going to change this to an x squared. This is actually just so the picture that we'll look at later is kind of cooler. But this thing is equal to, I didn't finish it, this thing is equal to 0. All right. So recall our squeeze theorem. So we have f of x is less than h of x, which is less than g of x. These can be equals near x equals a. And if the limit as x approaches a of f of x is equal to some number, which is equal to the limit as x approaches a of g of x, then the limit as x approaches a of h of x is equal to that number. If you don't remember this, just kind of remember the picture, right? Picture is this. We have some funky function h, and h is bounded between two easier looking functions. Whose limits approach the same thing, some value, in this case, right here. This is f and this is g. Then, if the limit of g approaches the same number as the limit of f, then the limit of h approaches that number. All right, so the key for things like this is we usually want to get an upper bound and lower bound, and with trig functions, that's actually pretty easy. We know, I'll say another recall, that negative 1 is less than or equal to cosine of any value, which is less than or equal to 1. So this is true for cosine of any value, so this should be true for cosine of 1 over x squared of any value. Okay. Here we maybe need to worry x is not equal to 0, but it's not since we're in the limit. Okay, so if that's true, then 5 to the negative 1 is less than or equal to 5 to the cosine of 1 over x squared, which is less than or equal to 5 to the 1. And I'm going to rewrite this as 1/5 and this as just 5. Now, I want to kind of further this inequality even more, multiply everything by x to the fourth, right, because that's what we have here. So x to the fourth times a fifth is less than or equal to x to the fourth times 5 cosine of 1 over x squared, which is less than or equal to x to the fourth times 5. All right, now let's check the limits of these simpler looking lower and upper functions. The limit as x approaches 0 of x to the fourth times a fifth is equal to, well, we can just do direct substitution here, 0 to the fourth times a fifth, which is just 0. And also, let me zoom out, and also the limit as x approaches 0 of 5 times x to the fourth is 5 times 0 to the fourth, which is 0. So now, by the squeeze theorem, the limit as x approaches 0 of x to the fourth cosine, 5 cosine to the 1 over x squared equals 0. So what you need for this question is this inequality here and these two limits. they're equal to each other, so we get the squeeze theorem. And then I said that the picture looks better with this, so I decided to just pull it up on Desmos. This is the function 5 cosine of 1 over x squared times x to the fourth. You can see it looks pretty funky. Let's see if I can, yeah, okay, that's good. And then now our upper bound was 5x to the fourth. And you see that it's a very nice upper bound. And our lower bound was 1/5 x to the fourth, which is the same thing as 5 to the negative 1 times x to the fourth. And there's our lower bound. Nice. It's a cool picture. All right, that's it.